The National Electrical Code, or NEC, is periodically updated, and these revisions sometimes involve relocating or renumbering sections. In the 2005 NEC, Section 220.35 from the 2002 NEC was moved and renumbered to 220.87. It is important to understand the purpose and application of 220.87. This section of the NEC addresses the concept of optional feeder or service load calculations for existing dwelling units. The purpose of this section is to permit a reduced calculated load for existing installations under specific conditions. It does not provide a method for calculating new loads or adding them to existing circuits. Instead, it offers an optional method for determining the existing load demand to see if additional load can be added. To properly address the addition of new loads to existing circuits, it is crucial to consult the relevant sections of the NEC that deal with branch circuit and feeder calculations. In this case, NEC 210.19a and 210.19 ATWO are the relevant sections that address the ampacity of conductors for branch circuits. These sections provide the requirements for the minimum size of conductors based on the load they will serve. NEC 210.19a generally requires that branch circuit conductors have an ampacity not less than the maximum load to be served. This means that when adding a new load, the existing conductors must be able to handle the additional current without exceeding their ampacity rating. If the existing conductors are not adequately sized, they must be replaced with conductors of sufficient ampacity. NEC 210.19 ATWO provides additional guidance for specific types of circuits, such as those serving continuous loads. A continuous load is defined as a load that operates for 3 IOs or more at a time. For continuous loads, the branch circuit conductors must have an ampacity not less than 125% of the continuous load. This is to account for the heat generated by the continuous operation of the load, which can affect the conductor's ampacity. Therefore, when adding a new continuous load to an existing circuit, it is essential to ensure that the conductors are sized accordingly. To accurately determine if an existing circuit can accommodate a new load, it is necessary to perform a load calculation. This involves determining the total amount of current that the circuit will be required to carry, including the existing load and the new load. The load calculation should take into account any applicable demand factors, which are factors that reduce the calculated load based on the assumption that not all loads will be operating at the same time. Demand factors are specified in various sections of the NEC depending on the type of load and the occupancy. Once the total calculated load is determined, it can be compared to the ampacity of the existing conductors to determine if they are adequately sized. If the calculated load exceeds the ampacity of the conductors must be replaced with larger conductors. It is important to note that the NEC also contains requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. The overcurrent protection device must be sized to protect the conductors based on their ampacity. When adding a new load to an existing circuit, it is essential to ensure that the overcurrent protection device is still appropriately sized for the new total load. If the new load causes the total load to exceed the rating of the overcurrent protection device, the device must be replaced with a larger one. However, the size of the overcurrent protection device must not exceed the ampacity of the conductors. In addition to the requirements for conductor ampacity and overcurrent protection, the NEC also contains requirements for the proper installation of electrical equipment. This includes requirements for wiring methods, grounding, and bonding. When adding a new load to an existing circuit, it is essential to ensure that all electrical equipment is installed in accordance with the NEC requirements. This will help to ensure the safety and reliability of the electrical system. In summary, when adding a new load to an existing circuit, it is important to first determine the total calculated load, taking into account any applicable demand factors. Then compare the calculated load to the ampacity of the existing conductors to determine if they are adequately sized. If the conductors are not adequately sized, they must be replaced with larger conductors. Also, ensure that the overcurrent protection device is appropriately sized for the new total load and that all electrical equipment is installed in accordance with the NEC requirements. Always consult the latest edition of the NEC for the most up-to-date requirements. The NEC is a comprehensive document, and it is essential to have a thorough understanding of its provisions to ensure the safe and reliable installation of electrical systems. The process for adding new load to existing circuits can be broken down into several key steps. Firstly, identify the existing circuit's capacity. Determine the existing load on the circuit. This involves identifying all the devices and equipment currently connected to the circuit and determining their respective amp draw or wattage. For resistive loads like heaters and incandescent lights, the wattage is typically marked on the device. For inductive loads like motors, the nameplate will usually indicate the full load amps. Secondly, calculate the total existing load. Sum up the amp draw of all the existing loads on the circuit. If the loads are given in watts, convert them to amps using the formula amps equals watts divided by volts. In a 120 volt circuit, a 100 watts light bulb draws approximately 0.83 amps. Thirdly, determine the new load. Identify the new device or equipment that will be added to the circuit and determine its amp draw or wattage. As with the existing loads, convert watts to amps if necessary. Fourthly, calculate the total new load including any continuous loads. Add the amp draw of the new load to the total existing load. If any of the loads are considered continuous, meaning they operate for 3 hours or more at a time, multiply their amp draw by 1.25 before adding them to the total. This is in accordance with NEC requirements for continuous loads. Fifthly, assess the circuit's capacity. Determine the ampacity of the circuit conductors. This is typically indicated by the size of the circuit breaker or fuse protecting the circuit. For example, a 15 amp circuit breaker protects 14 American wire gauge copper conductors, while a 20 amp circuit breaker protects 12 American wire gauge copper conductors. Sixthly, compare the total load to the circuit capacity. Compare the total calculated load, including the new load and any continuous load adjustments, to the ampacity of the circuit conductors. The total calculated load must not exceed 80% of the circuit's ampacity if there are continuous loads present. Seventhly, consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or even fail. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Eighthly, evaluate the neutral conductor. The neutral conductor carries the unbalanced current in a circuit. If the new load will significantly increase the unbalanced current, the neutral conductor may need to be upgraded. Ninthly, check for code compliance. Ensure that the addition of the new load complies with all applicable requirements of the NEC and any local electrical codes. Tenthly, document your calculations. Keep a record of all load calculations and other relevant information for future reference and for inspection purposes. For example, consider a 120 volts, 20 amp circuit that already has a load of 15 amps. A new appliance that draws 4 amps is being added to the circuit. The total load on the circuit will then be 19 amps, which is within the 20 amps capacity of the circuit. However, if the new appliance is a continuous load, its amp draw must be multiplied by 1.25, resulting in a load of 5 amps. The total load in the circuit would then be 20 amps. This is right at the capacity of the circuit, so it may be necessary to upgrade the circuit to a larger size to provide some headroom. Always consult with a qualified electrician before adding any new load to an existing circuit. The NEC is a complex document, and it is essential to have a thorough understanding of its provisions to ensure the safe and reliable installation of electrical systems. The NEC is updated every 3 years, so it is important to use the latest edition of the code. The NEC is not law unless it is adopted by a local jurisdiction. However, it is widely used as a standard for electrical safety. The NEC is developed by the National Fire Protection Association. The NFPA is a non-profit organization that develops codes and standards to reduce the risk of fire and other hazards. The NEC is written by a committee of experts in the electrical industry. The committee includes representatives from electrical contractors, manufacturers, insurance companies, and government agencies. The NEC is revised and updated every 3 years to reflect changes in technology and best practices. The NEC is a comprehensive document that covers all aspects of electrical installations. It includes requirements for wiring methods, overcurrent protection, grounding, and bonding. The NEC also includes requirements for specific types of equipment, such as motors, transformers, and generators. The NEC is an essential tool for anyone involved in the electrical industry. It provides a framework for the safe and reliable installation of electrical systems. Understanding demand factors is crucial for accurate load calculations. Demand factors allow for a reduction in the calculated load based on the assumption that not all connected loads will operate simultaneously at their maximum rating. This is particularly relevant in residential settings where various appliances and lighting fixtures are unlikely to be used at full capacity at all times. For example, NEC Table 220.42 provides demand factors for general lighting loads in dwelling units. The first 3000 volt amps are taken at 100% demand, while the remainder is taken at 35% demand. This recognizes that it is unlikely that all lighting fixtures in a home will be turned on at the same time. Similarly, NEC Table 220.52 provides demand factors for household cooking appliances. For 1 to 2 ranges, the demand factor is 80%, while for 3 or more ranges, the demand factor decreases further. This accounts for the fact that not all cooking appliances will be used simultaneously at their maximum power consumption. When adding a new load to an existing circuit, it is important to consider the impact on the neutral conductor. The neutral conductor carries the imbalanced current in a 3-wire, single-phase circuit. If the new load is a significant single-phase load, it can increase the current flowing through the neutral conductor. In some cases, the existing neutral conductor may not be adequately sized to handle the increased current. The NEC requires that the neutral conductor be sized to carry the maximum unbalanced load. This is typically determined by calculating the difference between the current flowing through the 2 hot conductors. If the unbalanced load is significant, the neutral conductor may need to be upgraded to a larger size. In addition to conductor ampacity, voltage drop, and neutral conductor considerations, it is also important to ensure that the new load is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The NEC requires that all electrical equipment be grounded in accordance with its requirements. This typically involves connecting the equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding conductor must be sized appropriately for the size of the circuit conductors. It is also important to ensure that all connections are made properly and that the grounding system is properly maintained. When adding a new load to an existing circuit, it is essential to consult with a qualified electrician. A qualified electrician has the knowledge and experience to properly assess the existing electrical system and determine if it can safely accommodate the new load. They can also perform the necessary load calculations and ensure that all work is done in accordance with the NEC and any local electrical codes. Attempting to add a new load to an existing circuit without the proper knowledge and experience can be dangerous and can lead to electrical shock, fire, or equipment damage. Always err on the side of caution and consult with a qualified electrician before making any changes to your electrical system. Understanding the different types of circuits is also important when adding new loads. Branch circuits are circuits that extend from the final overcurrent device to the outlets or equipment they supply. Feeder circuits are circuits that carry power from the service entrance to one or more branch circuits. Service entrance conductors are the conductors that bring power from the utility company to the building. Each type of circuit has its own set of requirements in the NEC. For example, branch circuits must be protected by overcurrent devices rated at not more than the ampacity of the conductors they serve. Feeder circuits must be sized to carry the total load of the branch circuits they supply. Service entrance conductors must be sized to carry the total load of the building. When adding a new load, it is important to determine which type of circuit it will be connected to. This will help to determine the applicable requirements in the NEC. Also, understanding the use of the appropriate wiring methods is also key. The NEC specifies different wiring methods that can be used for electrical installations. Some common wiring methods include non-metallic sheath cable type NM, rigid metal conduit RMC, electrical metallic tubing EMT, and flexible metal conduit FMC. Each wiring method has its own set of advantages and disadvantages. Type NM cable is relatively inexpensive and easy to install, but it is not suitable for use in wet or hazardous locations. RMC is very durable and provides excellent protection for conductors, but it is more expensive and difficult to install than type NM cable. EMT is a lightweight and versatile wiring method that is suitable for a wide range of applications. FMC is flexible and can be used in tight spaces, but it is not as durable as RMC or EMT. When adding a new load, it is important to choose the appropriate wiring method for the application. The NEC specifies which wiring methods are permitted in different locations and for different types of occupancies. It is also important to follow the manufacturer's instructions for installing the wiring method. In addition to the NEC, there may be local electrical codes that apply to electrical installations. Local electrical codes are typically based on the NEC, but they may include additional requirements or modifications. It is important to be aware of and comply with all applicable local electrical codes. Local electrical codes are typically enforced by the local building department or electrical inspection agency. These agencies may require permits and inspections for electrical work. It is important to obtain the necessary permits and inspections before starting any electrical work. Failure to comply with local electrical codes can result in fines or other penalties. Remember that adding new electrical load to existing circuits requires a thorough understanding of electrical principles, the National Electrical Code, and local regulations. Always prioritize safety and consult with qualified professionals when in doubt.